I counted 40 minutes with the questions, so I have. No. I will try to be. I want to have questions. I want to be an interactive session.
Welcome back for a new session. May I please remind you about the feedback. Don't forget to log on to the DevConf website /feedback and leave your thoughts about the presentations that you're attending. And also don't forget in 40 minutes after this presentation to go and pick up your ticket for the party tonight. That being said, let me introduce Zdenek, who's going to tell us how to be compatible in userspace.
So, hello, I'm Zdenek Kabelac, and I work for Red Hat as a senior software engineer for quite a few years, as a team member of LVM developers. And I've been asking Radek for if I should give this year another presentation about LVM, and he said that he would like to prefer to get a real developer talk. So I hope there are not people who expect to learn something about LVM in terms of command lines, but I assume that you all came here as developers and you want to either learn something new or maybe you will teach me something new. Please feel it as an interactive session. So if we do something wrong, let's fix us. And if we do something good, so you can learn from that. So what is my talk going to be about? I think everyone knows that the kernel, Linux kernel, is compatible forever. So the API from the kernel space is kept forever compatible, and you can rely on it. The problem is that in user space, it doesn't apply at all. So what we will talk about. I will first mention what I mean by compatibility and why we should be compatible. Then few words, or not a few words, but I will talk about what does it mean to write project in a compatible way, and I will mix it in with our LVM solutions. So there will be few words about the solution there. I will even show you code from LVM to demonstrate how we will do the things. So why being compatible? I often hear from my colleagues that they complain that they have to maintain a huge set of backported patches and they have to work on many releases at the same time. In LVM, we take a different approach. We maintain one single upstream branch, which, on the other hand, has to be compatible for all releases. So we have the same code base for Fedora, Rawhide, Fedora 21, 24, 23, Rails, and also that applies to Ubuntu and other distributions. The other reason why being compatible makes sense is that you often may want to do a git bisect. And if you want to do it on a system which is maintaining compatibility, it's easy. If you do it on a system which has systemd and udef and things like that, the bisect gets somewhat more complex than you would expect, because you not just solve the problems for compiling your tree, but you have to also change the old your tree to apply to the new state of your machine. So it's often quite complicated. Then the other thing, which at least from our perspective is lesson learned, you often figure out after even many years that you caused some regressions, either in performance or in command line parsing, for example. So checking for these things is often quite a good reason why to be compatible. Of course, by doing your project compatible, you support your users. They will be grateful for that because you make their life easier. And sometimes I miss that from other projects. And of course, the very important point is that others may depend on you. So if you provide a compatible API and you stick for that for many years, then other users will depend on it and will trust you that you are doing your work good, in a good way. So otherwise, you are in the risk of this famous strip where basically the people come in and see, okay, this is incompatible. I will have to rewrite and do another project to do this stuff. So to avoid that, develop in a compatible way, and you will eliminate most of these situations. So this talk is not going to be about reproducing the Ulrich Trepper talk, which is quite old already. So it was, I think, released in 2002. Available on this URL. But I will mention what we do for the compatibility. So one take on that is that you want to be compatible on the compile level. So you provide some header files, functions, structures, and you want to maintain the compatibility on the compile style level. This is relatively easy compared with the two other points. You mostly get instant warning from the compiler. You just need to check on all the distributions that you are still compilable. If you want to be a low-level library and you want to use the latest, greatest features of your compiler, well, sometimes it's not a good idea. So if you really not need them, avoid them. So if you, at least for our project like LVM is, we do not need to use the latest extensions of GCC. So if you stick with this, or at least you provide wrapping defines, then you should be fine. But you need to check it. Basically, you have to run your builds on multiple distributions and check that you are not causing problems. I will show at the end of the presentation how we will do it. And now the binary compatibility, which my talk is going to be mostly about, or a big portion will be about. We have two kinds. One is backward, which means that if you install your new library, it will still run the older software. So that also means that the output of the older software is consumable by your new release. So basically, whatever writes the old software is readable by your new software. In terms of LVM, for example, the LVM metadata are readable and usable. The other one, the forward, is much harder one. That basically means that you have to think to the future. So if you have an update in the future, you should not, your new tool should not cause destruction of the older tool. So if you have like daemons which are communicating with each other and you upgrade them, and suddenly the new daemon starts to throw a new type of data, it should not cause the core dump of the old one. There should be a communication versioning, and the old tool should recognize that it does not understand the new language, but it should not crash like it happened for us, for example, also. So these are all lessons learned. So runtime upgrade is something where I think the system is still not doing the best it could. And we try to keep the state of daemon, pass the state of the daemon to the new version, and run the version in a new version and keep the same data. So this compatibility is much hard to think about, but you should not forget about it. So now I will say a few words about how we add the symbols in the library, or how we change things in our library. I should mention that we talk about the lib device mapper library, because that's the only library we provide as a compatible, in a compatible way. So exporting symbols means that you provide correct versioning for each new symbol. There are a few ways how to look on that, and we will demonstrate it on the source code. Let's see. So if you, I don't know, any one of you are playing with those tools like readelf and checking symbols in the library, ever try that? Okay, good. Anyone else? So how many of you are versioning your symbols in the library? Never ever? Well, you should start with that, because that's what allows you to keep the compatibility to the future. So basically what you have to do is to generate a file which has some structure. Basically you can have some names, and you can specify the function names. You end it with a local one. So basically you have a full control over what is exported from your library. So you really should take care of that, and you should not export functions you don't want the other users would use or see. It's important, because otherwise users will start to use even functions they were not meant to use. They were hidden for your usage, maybe, but they were not meant as an API. So you are in danger that users will look at the source code and start to use functions that they should not really use. So keep this in mind and hide all other functions. Only export what you want to export and what you want to support. That's important thing. So the fun begins when you realize that you made a mistake in your API. I'm here talking just about the C interface. I'm not going to talk about the C++. Basically, one of those things is that LVM is still in C, and probably will stay that way for a long time. But even in C, you can make mistakes. In C++, it's much harder, but in C, if you forget that the structures have sizes and you are not returning those structures as an allocated block of memory, but you expose the structure in the header file, and you realize that you want to extend your structure in your header file, then adding new members to the structure seems like a natural way how to extend it, and nothing bad can happen. Unfortunately, that's not true. Of course, if you recompile all your software, everything will work, but then you have a problem that you can still have a users which do have newer, older header files, compile the older software, and try to use it with your new software. And then suddenly some structures passed to your new library will not match in size. So this is something you have to take care about. And how to do it? So you will have to provide multiple functions for the same functionality. It's good for you if you can match the functionality in one newer function, and you just add wrapper functions to provide interface for the old users. So basically, what we do in LVM, and what I will show you right away, is that we create a new function which has the proper versioning. We stick with the DM and version number. So now you will have multiple symbols in your library. One will be with the base. That's basically the sign where we were not realizing we have a problem. We still use the base. And from the new version, from the new for the new function, we will have a new version. And now how it looks in the source code. Okay. First, maybe I will first show you how we started to generate these version symbols. We basically, when we create a new function in a library, we put the definitions here in the single file. So we now, from version 97, track all the history, how we add the functions. And we combine them in a final file through the rule, make file rules, and how it looks in the code. So let's find VM task. So here we have a new function which takes a new structure, and this is a function which gets the latest, greatest suffix with the version 97. And we provide an wrapping at the end of file. We have the logic in the end of file for the old functions, where we call the function get task get base. Here. And this function has no other functionality than taking the structure with the old size, remapping it to the new size, and calling the new function. So there are no problems with reading out of memory places. So basically, that's all we have to do in this case. So it's not an excuse that if you have to change the structure, you do not really need to release a completely new version of incompatible library, like we see many times that developers realize that they have made a mistake and generate a new versions which are incompatible and cause quite some troubles to many other users. So it's okay if you just develop some plugin for some GUI tool, whatever, but if the whole GNOME library works in a way that even the minor changes cause that you have to throw up all your plugins, it's not the way it's been meant to be used. So back to my presentation. So is this somewhat clear to you, or should I say a few more words about that? Okay.
Can you maybe show what this macro is doing?
Well, I just provided at the end of presentation, I provide the link to LVM sources. It's really complicated because we have also quite complex makefile to process those exported names. We even detect the problem if we provide a new function and we have forgot to put the new function in the proper file. So we spent quite some time on that. So I can probably show you after the presentation. So now, what are the other problems we were not realizing? And we realized that after we spent a while on figuring out what the bug report means, because we were receiving the bug reports that users are getting strange core dumps, and they are installing the libraries, and it's not working. And we were looking at the core dumps, and it's been showing that they were just accessing the memory from functions which were just looking all fine, and it was not possible to explain. Then we asked what the user did, and he told us, well, we used the latest Koji to build the new library, and we first installed this new library to use with our old project. So we said, oh, we have to somehow prevent to do that. And how to do it? Well, there are a few things I was not aware. I came from the Debian world, and in Debian, you store the dependencies in a very strict way. So when you build a package, you store the dependencies on other packages in raw form. While on RPM, the libraries are expressed differently, and you express dependency on the symbols. So in RPM, it's not strictly limited which library will be used. It has just to satisfy the versioning. So whoever thinks that the so-named minor version solves your problem, it will not. You will just cause the incompatibility for the package maintainers, but it will not solve your problem with the loading libraries which do not have right symbols. So basically the problem with the structure resize, okay, I think it's not working anymore. Is it working? Oh, I have wrong focus. These structure changes were not captured well by the RPM. So we had to think about how to do it. And if you check with RPM commands what the libraries are requiring or providing, you will notice that it's not just glibc 6, but also there is some extra symbol, and that's what we learn to use. So basically, this is the way how you will ensure that the users of your library will map the right functions for their binaries. And we can see that even in, let's see. Device mapper. And you can see that now device mapper package contains the tool called DM setup, and DM setup has dependencies on all these symbols. So whichever package provides them, it will satisfy these dependencies. So there is one strict dependency from building the package, but it's not what you will get if you are using the device mapper library. So this is what you will use in your package to bind the library properly. So the other important thing to think about is what you should do when you add a new feature to your project. And that relates to the fact that we have one single code base for LVM. So we have Rails 6, Rails 7, still in the single tree. We do not develop multiple feature branches and fix bugs fixed in the Rails 7, in the Rails 6, and so on. So things to think about. If you add a new option, you should provide a configurable configure option to disable and enable it. So if you are sure that you do not want to provide a new feature to the old distro, you should do it in a configurable way. So the package maintainers of distros may select by single configure option line what they want to have compiled or not. They should not start to play diffing and patching your binaries just to disable something which they are not or they do not want to use. Then the other thing is you should also provide, if that makes sense, if it's something that users may want to use, you should provide configurable defines, because defaults may change from distro to distro. In one distro, usage of something might be a default, and in other distro, it might be disabled. For example, in LVM, we have daemons, and you want to have them supported in Rails 7, and you want to have them disabled in Rails 6 because they are not supported or not supportable. So when you add new option, think about the configure options. LVM has also very extensive runtime configuration file, and we recently even scaled up massively this thing, so we can generate configuration files for a given version, do a diffs between versions all the runtime. So these options you provide in the build time, you should let them configurable also in the runtime. So when you install your package and you want to disable or enable features, they should be all that should be all doable in runtime. The thing that developers often forget about is documenting and testing. We also sometimes fail to do it. Sometimes new features flow in such a big flow that some pieces are missing, but we usually try to catch up. So don't forget, whenever you add something really meaningful to documentation, man pages, and also the feature which is not tested, it's like does not exist. Because if you work in the team where multiple developers are developing and the features are not tested, then it often happens that one coder commits something and breaks something else. And when it's untested, it's lost and forgotten, because if you have like thousands of features, you do not have time to play with all the features. So testing is important part. Example from LVM, when we added, for example, feature where we switched snapshots from the old style to using the thin provisioning, you may select the type at the configure time, and you may also select it at the runtime. So if the user is not satisfied with the new defaults, he has still the chance to go back and use the old one. And we also have, if we figure out that we have a mistake in the new feature, we can also suggest a very simple bug fix for the user. The bug fix in terms that if the user had a previous functionality working, and now we break something for him, like we caused the serious regression in some performance, for example, we can just tell him, okay, we will try to work on that, and meanwhile, you can disable the new feature and go back to your old previous settings. So now, testing. Okay. When you add a new API functionality and you are not quite sure if that's going to stay that way, you should mark the API as unstable, and you should try to resolve this rather early, so the users are not seeing for years this API is unstable. So it's fine to release the unstable API, it's fine to change it, but you should not keep it forever in the state. And the versioning makes even possible to, even this, if this unstable API is not so much broken, you can still keep it in a shape in terms of those version symbols. So even if you change the API later, you still may keep the compatibility in some way. Whenever you do a commit, especially if you introduce a big feature, do not forget about the test cases. Also a problem in LVM, not always this is true, but we try. And that's, as I said, if you have a lot of features and those are interacting with each other, you may easily lose them. And what is not tested often appears as a bug with 3, 4, 5 years regression. So that's why we occasionally have to go back in quite a big history to see when it got broken and how to fix it. What I personally do not like very much is that you really should not release the stuff you have not tested. I often see, especially in Rawhide, that it seems like the package maintainers do not even test what they have built. So please, if you try to do compatible software, think about your users. They are not your lab rats, really. You should check it yourself. And well, enough about that. And 10 minutes. And let's see what I have here from LVM. Now it's there are many other projects how to test your stuff. We in LVM team developed our solution somehow in-house, and we use the Billbot, and we with each commit we basically test suite, which is virtualizing the whole usage. So we collect test cases, we try to add more and more of them, and we also try to use more machine types, like we check on RHEL 6, RHEL 5, RHEL 7, Fedoras, even some Debian. Other thing is that we do use the static analysis. We find the reports from tools like Compatibility and so on. Very useful. Also prevents you breaking the code. So let me demonstrate the tests we run. So what we have here. So how it looks like. This is basically a list of machines. Could be extended more easily. And every commit causes the whole build of the whole project. So by this we catch that we are compilable by on many different distributions. We also try to use slightly different options and configure settings on those distros. So we try to check for different pieces because there are many combinations. So we even had some other testing machines, but they are currently disabled. So as you can see, some machines are slower, some are faster, some are even showing that there are bugs, which are at this moment it's the rawhide machine, and by our test suite we catched the mistake which made the author of SCSI debug mode driver, where he basically switched the sectors to bytes, I think. So it's now reporting different numbers, and our test suite is catching that. And we are quite surprised that the author itself has actually not tested this thing, and many other sign-ons on this commit, which seemed like it has been verified by, I don't know, 5 other people, did not do the same. So as you can see, we catch that mistake. I think it will be soon repaired. So the other noticeable thing in our output, which let's see back. So let's see this. We also have several modes of running, like in terms of we have like virtual mode of DM, and we have also a full setup of machines. So we provide complete RPM packaging, and we provide single testing. And the advantage of this is that we can log on the machine and simply check in real what happened there. And the other thing our test is doing is we also detect the time of test, so we can check for speed regressions and other things like that. And I think it's enough. And now it's time for your questions, if you have some. Okay.
Can you go back to the example of the size of the structure? Would not it be better to just define the API such that the size of the structure does not matter?
Well, as I said, if you have a project which already has an existing API, you cannot throw it out and build a new
So
project.
this is to
Yeah.
fix mistakes that
Yes,
were made
yes,
before.
yes. But as I said,
the recommended way to
yeah,
start
the correct way, of course, is to return the structure from the library. So it's obvious that. But if you had already an existing API which has been designed like, I don't know, 12, 15 years ago, you cannot just, you can throw it away and you can build new library, but again, that's what we try to prevent. We want to have one stable library which users may rely on, use it, and we solve it differently and it's usable. So that's what the presentation was about. Of course, we know, of course, yeah, of course, yeah, of course, it makes bigger sense to think ahead, but my point is that if you even have all the library, you can still provide the compatible interface, glibc, and provide the support on GCC, and everyone should check the Uli Depe presentation. There's a lot of things explained in big detail, so that's so another question? Okay, go on.
So now you have all this wonderful experience how to make the compatibility work across the systems, which is actually great. So now when you do have this experience, when is going to be LVM library ready?
Yeah, so the question is that when we do libdm or lib device map library, when we do LVM library, the question is LVM library will not exist in terms of you will be able to link the library with your code, but we are now focusing on providing the dbus API. So the issue, I think I do not want to bother other, so I can explain why there cannot be linked library, because there are many memory restrictions and other restrictions that your tool cannot really handle, especially if it's in Python and stuff. So basic story is that we lock the memory to the application into the memory, and we really do not want to lock 300 megabytes to the memory because of Python. So, okay, another question?
Are you using some tools to find out the API diffs between the new library and the old libraries? For example, the package diff?
Oh, yeah, well, yeah, that's what we get when we run the package Wrangler or whatever the tool is. When you build the RPM packages, you get a list of differences and you have to accept them, so waive them or whatever. So there are tools which are checking for that, but on the other side, we are not extending our library so heavily that we would add 20, 50 symbols per release. So it's relatively low flow of new news into the library, so we can do it by hand. And there are 3-5 people watching the commits, so that's basically it. I understand that if you would have a project which generates a huge API changes every month, then it's a problem. But in our case, it's few functions per month or so. So there was a bigger change recently, actually, when we added DM stats into the library. But other than that, it's if you I can show you just here. As you can see, only the version 104 has a bigger set of changes. All others are just 1-2 functions. So, okay, another question? Out of time, so you can ask me after.
May I please get the presentation?
Aha, jsem to nevypnul.
It's okay, it's okay.
USB?
I have a question. Do you happen to know a link to make compiler link with other versions, symbols?
Yeah, I will show you how we will do it in Alien.
This wrapper?
Especially HUC, that is very useful.
You want PDF, right?
Well, if available, it would be better.
Maybe how to write.
Compatibility users.